In this video, we will be talking about properties of waves, which fulfills the MSPS 4-A learning standards. So there are two types of waves, mechanical waves and electromagnetic waves. We will only be focusing on mechanical waves in this video. Mechanical waves have two separate types, longitudinal waves, which are sound waves, and transverse waves, which are water waves. So longitudinal waves, the source moves from left to right. Just as if you were compressing a spring, the coil would move from left to right. So in a transverse wave, the source moves up and down as the coils move up and down. So think of holding a string and just moving it up and down while your friend is holding the other end, and the string will be moving vertically and not horizontally. So longitudinal waves, some of its properties. So there are points where it is more dense, so this would be the compression, and there are points where it is less dense, and that is called rarefaction. The amplitude of the wave is measured from its equilibrium position to the top of the wave, and the wavelength is measured from compression to compression. A transverse wave has crests, which are the high points, and troughs. A wavelength is measured from one crest to the next crest. And again, transverse waves have the amplitude, which is measured from the equilibrium position. A real-life example of transverse waves would be waves at a beach. You could measure the wavelengths, the crests, the troughs, and the wave heights for a beach wave. In this example, it shows the outline of a water wave. What are the values of the amplitude and wavelength? So the amplitude, as we know, is from the equilibrium to the top of the crest. So in this case, it would be 0.6 centimeters. The wavelength is measured from crest to crest, so it looks like this one is at about 5 centimeters, and this one is about 25 centimeters, so 25 minus 5, the wavelength would be 20 centimeters. For longitudinal waves, wavelength is measured again from compression to compression, so we can see that the distance between the compressions is 100 centimeters, so that would be our wavelength. The amplitude is measured from equilibrium position to the top of the wave. In this one, it gives the whole height of the wave, so we know that it would just be half of that number. So our amplitude would be 5 centimeters. So a real-life example of longitudinal waves is when you hear sounds, the compressed part of the wave is hitting your eardrum. I hope this video helped.